Good afternoon, everyone. Welcome to the HKAE TechTalk. The HKAE TechTalk series is jointly organized by the Hong Kong Academy of Engineering, or HKAE, and also Hong Kong U. And the purpose or the objective of the series is to promote the latest developments in innovation and technology among the public. And today, we are very honored to have Professor Xin YAO, who is the Vice President, Research and Innovation, the Tong Tin Sun Chair Professor of Machine Learning, School of Data Science of Lingnan University, to give us a talk on the topic of from trustworthy system to trustworthy AI. Our honorable speaker today, Professor Yao, is an IEEE Fellow and a Fellows of the Hong Kong Academies of Engineering. And Professor Yao served as the president of IEEE Computational Intelligence Society, and he is also the editor-in-chief of IEEE Transactions of Evolutionary Computations. Professor Yao's major research interests include AI ethics, evolutionary computation, neural network ensembles, and multi-objective machine learning. Professor Yao, because of his outstanding research work, has won a lot of awards, and these include the 2001 IEEE Donald Fink Prize Paper Award, 2010, 2016, and 2017 IEEE Transactions on Evolutionary Computation Outstanding Paper Awards, among others. Professor Yao has also received several very prestigious awards, which include the 2012 Royal Society Wolfson's Research Merit Award, the 2013 IEEE CIS Evolutionary Computation Pioneer Award, and also the 2020 IEEE Frank Rosenblatt Award. Well, without further ado, may I invite all of us to join me in welcoming our speaker, Professor Yao.
Thank you. Thank you. Yeah. Thank you very much for the kind introduction. So today's talk is more about my recent work, where I got very interested in the softer side of engineering, especially given this overall environment where we call for engineers to be more socially responsible, so to speak. But socially responsible is a very qualitative description. And then for someone educated to be quantitative, there's a lot of challenges. And let me show you some of the challenges I faced, and then I'll go with the flow over the last few years I experienced. So my talk really has 5 parts. I think the first one and the last one are very basic. First one might be important for those of you in hardcore engineering. I think it's a very important one. And then middle 3 are the ones I want to go through to give you a bit of flavor what I've been very interested in myself. Firstly, about trustworthy systems. So more like a disclaimer. Just in case someone said the trustworthy systems are new, you can tell them, well, at least in science engineering, they are not new. They are decade-old concept in terms of trustworthy system, trustworthiness. They are used in traditional reliability engineering. They are used in the telecommunication engineering, in many engineering disciplines. Now, let's learn from our textbooks. What does it mean to be trustworthy? The trustworthy is an extremely popular word. So if you look at the science engineering literature, you kind of converge to 6 attributes. If you want to call a system to be trustworthy, you need to consider resilience, security, privacy, safety, reliability, and availability. Some of these properties you have heard quite a lot: reliability, safety. Some of these properties you might not have heard very often within university. Okay? For example, availability. Not many professors teach you about availability, but when you move outside this campus, it's very important. You cannot build highly reliable system, but cannot guarantee availability, okay? But to keep this in mind, traditionally, people have converged to a consensus for a system to be trustworthy. You need to have these 6 properties. So as engineers, okay, I want to build trustworthy systems. Let me give you one example so you can relate this kind of abstract concept to reality. Aircraft engine must be a trustworthy system. Okay, so that's a trustworthy system. If we want to build an engineering system, you start with the requirements. If you rush to build anything without requirements, I can guarantee you the system will fail. Okay. Now, what kind of system requirements you will have for trustworthy systems? From the literature, you can get it very easily. Okay. Just you wonder why there are 7 system requirements. Previous slide said only 6 properties. Because the 0th one, the most important one, is no matter what system you build, the system should do what you want the system to do. Okay, so the system will always realize its intended business functions. And then you have the other 6 requirements which describe, elaborate more what those words actually mean from engineering sense. If you build an engineering system, okay. So if you look at requirement 1, it's actually set the potential adverse conditions of the system are adequately analyzed, addressed by design. You don't build a system and then test it, you do it by design. Okay. The system able to guard against and withstand adversities in a continuously improving manner. Although it's a classical engineering field, it's actually quite challenging. Thinking about the software, hardware systems you built, how many of you can be described a system can actually withstand adversity in a continuously improving manner? Most systems don't do continuous improving. Okay, so anyway, I won't go down from the system requirements 1 to system requirement 6. I just want all of us to recall this actually the existing body of knowledge we have accumulated over the years in engineering domain. Okay, so that's an introduction about trustworthy system. Now you have this buzzword called trustworthy AI. AI must be trustworthy. Well, of course, but tell me, what do you mean by trustworthy? Okay. So what does trustworthy AI mean then? So is it the same as what I described before? I always say it's very important to ask this very simple, basic question. Because a university professor has this tendency of inventing buzzwords in order to get the grants. Okay, so you need to be very careful, okay? So next time, when somebody tries to sell you, AI must be trustworthy, then maybe you can ask kind of a gentle question. Will your trustworthy AI already considered the 6 properties and the 7 requirements, which were considered by engineers a long time ago? If you can't even do that, then you are going backwards now. More interesting thing is if we do use a buzzword, trustworthy AI. A buzzword is also important because you want to get public and the politicians' attention, and then you have a hard work in explaining what's new in your buzzword, which was not there. Okay, so are there anything new in trustworthy AI which is not in trustworthy systems? If no, then it's really the professor playing the game. If there is, what's that? And that bit will be the interesting research part. Okay. Before answering that question, let's turn this around. I'm going to show you some examples of untrustworthy AI. And hopefully that can lead you to think what might be trustworthy. So on the left-hand side is this Google Photo app. Well, if you take out your mobile phone, you have this photo app, and if you check your mobile phone, it actually tagging to all the photos, right? There's a building, a city. And then on the left-hand side, that tag was wrong because, yeah, this is very offensive. If you are not black, you might not feel it, but if you are black. So that app was actually deployed and took offline in less than a day. Now, if you see all this photo tagging software, they don't tag very precise information. They always give you very generic labels. Just try to avoid this mistake from happening. Okay. And then this is for those slightly older, before large language models. There are quite a few chatbots. One of the most well-known chatbots is actually from Microsoft. Okay, Microsoft Tay.ai. Within mainland China, there's called Wenwan Xiaobing. It's just a chatbot. And this one is actually was deployed into real system tweeters. Again, it was taken offline in less than a day because it started swearing at the people when you chat with it. Okay, so all these examples, although I don't want to use this software, okay? I don't want to be offensive. I don't want to swear at the people. It's just not good. Okay. Then you might say, well, this is a very old example for those of you with very sharp eyes, engineers. You see, this web page dated 2015. For 2015, for computer scientists, this is dinosaur age. Okay, it is not very good using this example. Now, let me fast forward. This is reasonably recent. Okay, 2025. It's in the news. Okay, you don't have to be a scientist or engineer to look at it. In the US, a parent of a teenager who took his own life sued OpenAI. So that's actually in the news. Because the teenager committed suicide, and then the parents and the prosecutor checked the mobile phone conversation between the boy and ChatGPT, and they found ChatGPT played a role, telling the boy how to tie a knot and how the knot would be tighter with a weight. And in the thing, the knot tied by the boy is exactly the same as described by ChatGPT. And then the parents, of course, was very upset. So I think is it a trustworthy need for the AI? Now you probably say, oh, come on, Professor Yao, you're a professor, right? You don't really read the BBC News as a scientific evidence. That's more like a tabloid thing. Now, let me show you something more serious. This from Science magazine. You cannot be more scientific than the article published in the Science magazine, right? And then they actually have a title published under research article rather than published under letters to the editor. So it's very serious stuff. And then it actually reveals a racial bias in health algorithms being used in the US. Okay, it's a fact. What happens? What's the bias? So black patients assigned the same level of risk by the algorithm are sicker than white patients. Oh, that's not good, because human lives are at stake, okay? Everything is saying one black, one white. And then they always said, if you turn kind of quote positive, they always say, oh, these black people are healthier. You don't need the treatment. Okay? So, not good. So if we look at those examples, and then you step back to the question, what's in trustworthy AI, which might not be in trustworthy systems? So all these examples I show you, you see, they are very soft. They are not traditional reliability, availability, or this security thing. They relate to some kind of what I call the soft principles: fairness, equity, responsibility, etc. So this is actually all captured by a large concept we call AI ethics. Okay. The reason I summarize into AI ethics, just recall the literature you are reading now, I mean real scientific literature. Don't you think you are encountering more often the words like transparency, explainability, responsibility, justice in scientific papers, not in just news? It just shows even in science and engineering, these so-called soft principles are increasingly important. Now, not important just because I'm social scientists talking about it. It's because these are real life examples. The system just cannot be deployed. Okay, so all these, I claim, is a part of ethics. Not only there are far more examples than I just presented to you. So here's the first key message I claimed for my talk. So if you ask me, what's trustworthy AI? And I write it as kind of a simplified formula. Trustworthy AI, in my view, is the traditional trustworthy systems plus AI ethics. We can always debate whether my claim is correct or not, and I hope there are more debates such that we can really clarify this. I questioned at the beginning that whenever we talk about the trustworthy AI, we must not forget what we have learned in terms of trustworthy systems, but in addition, because AI systems interacting with us and decide on us directly now, ethical principles are extremely important. So that's trustworthy AI. Of course, you can always keep asking the question, so what is AI ethics? Ethics is actually extremely well-established research area for over 2,000 years. Okay, so either in the West or in the East. But in terms of AI ethics, we did a very straightforward survey a few years ago, looking at guidelines published top level from the United Nations, bottom level to the city government, okay, national guidelines about AI. And then you can scan through those documents, extract the keywords. And then you see what keywords occur the most often. Okay, so that's the exercise I'm going to show you. Out of these 146 documents, now it's actually far more than 146 now, so this was done a few years ago. I'll skip this. So now you can see, you get slightly more concrete idea what AI ethics might include. At the top of the list, among 146 documents, 107 all mention the transparency, fairness, and justice. These are the synonyms when we do this keyword count. So whenever people talk about AI ethics, I think they care about transparency, they care about fairness and justice a lot. So if you are in the business of spinning off another AI startup, please pay attention to this. Otherwise, when you deploy the system, they are going to come back to bite you. Okay, so if you go down this, it's reasonably comprehensive, but by no means comprehensive. You have responsibility, non-beneficence, so this is actually extremely relevant to autonomous driving. And there's privacy we are very familiar with, beneficence, freedom, economy, solidarity, sustainability, trust, and dignity. Okay. Sometimes you probably wonder, what do you mean dignity? Well, if you are in the autonomous vehicle domain, if you are into autonomous devices for the healthcare, only care domain, dignity is actually very important if you want a system to be adopted. Okay, so this is just one summary for those of you who are not interested in doing research in this area, but want to get just one slide summary what kind of ethical issues might be there. So I'll encourage you to think at the level of individuals. There are safety, privacy, etc. issues. There are ethical issues related to groups or within a society. Fairness kicks in when you have multiple people, and the responsibility, transparency, etc. And then even at the environmental level, at the global level, there's a natural resource issue and energy issue. Let me just give you one number. Some of you might know already. In the most recent AI index report published by Stanford, I think last month, appeared. Do you know how much water large language model consumes just for inference, not for training? Normally people thinking about electricity, right? Do you want to guess? How much water a large language model will consume just for inference? It's equivalent to the drinking water for 1.2 million people. It's very interesting because most people focus on electricity consumption. Then I keep asking my postdocs, if I have two choices, you can keep use API to call large language models, but every time you call it, you'll drink less water, okay? Now you make a choice. So it's very interesting. So you are sucked into engineering problem when you step back. I think you get slightly different perspective. So this is actually really about taking a broader perspective about this narrow engineering problem in terms of large language models. So this slide I won't go into detail. This is really illustrate as engineers, we build systems. When we build systems, we look at the life cycles. And then at every step of the life cycle for AI systems, start from business analysis, data engineering, model training, model deployment to operation and monitoring, there are ethical issues you must fulfill. Whether it's because of regulatory requirements or because of industrial standards, or because something you should do ethically, okay? So this is all in the literature. I won't repeat that. Now, this slide is really used to capture at a very sort of a broad scale in terms of what kind of potential risks AI might bring in spite of all these benefits, and then what kind of responses social scientists has come up with, right? And then, so there is one website maintained by MIT researchers identify more than 1,700 AI risks. It doesn't mean we should not do AI, it's we need to be aware of that. And then if you look at what kind of regulations or responses or governance methods people put it in. So there's a recent paper, well, kind of recent, 23, people looking at over 200 national guidelines and a recommendation for AI governance. So we need to push technology forward, but we need to be aware of the risks, what kind of mechanisms we can put into place to mitigate these risks while we are advancing the technology. So, okay, I said something about trustworthy AI, and I raised awareness that there are unresolved issues, especially ethical AI. What should we do? So I want to say a little bit about this AI governance. If we look at the approaches towards trustworthy AI, especially taking care of these ethical aspects, which was not featured in classical trustworthy systems. Because I always use the example of aircraft engine. You rarely talk about the responsibility of aircraft engine, right? Ethical aspect aircraft engine. But for AI system, you do have this inherent ethical aspect to it. And then if we divide it into these non-technical approach or technical approach, for non-technical approach, it's very easily said, but very difficult to implement because at the regulatory level, you can introduce some laws, you can introduce industrial standards, you can introduce some self-regulations by a group of companies. Okay, so all levels can be introduced. But when you introduce this, the very first reaction is no, yet another government regulations. So for those of you who are very interested in AI, you know EU's Artificial Intelligence Act has officially been in effect. But there were a lot of complaints, okay, especially in Germany, in some sort of better developed AI countries, so to speak, because they worry about these constraints in terms of innovation. And this is actually not a new problem. This is actually a research topic probably for the last 30 or 40 years. There's always kind of a regulation versus innovation there. Are we going to introduce additional administrative burden to AI researchers or developers and users? When I gave this talk at a different forum, people said, wouldn't this regulation really about user developers? I'm just researchers. I'm the one writing the algorithms. Why should I care about this? So let me give you a very simple scenario for autonomous driving. You know this robot taxi has been running in part of China and part of the US. For example, in Guangzhou, if you go to certain regions in Nansha, there's autonomous car. Assuming there's an accident involved in this car, then how do we apportion the responsibility? Suppose I own a car. You say, well, you are responsible, the car has an accident. Then I was saying, I just bought this car from that dealer. I didn't do anything. I didn't even drive the car. I bought it. And the dealer said, I didn't design the car. The car's from, I don't know, from whatever the company in Finalist, let's say, okay? Then you ship to the dealer. And then Finalist say, I didn't do anything. The autonomous driving part was developed by Huawei. I just put a box around it. And Huawei said, I didn't do anything. Professor Yao did the algorithm. Okay, so you can see when you have this new AI system, I don't think even as a so-called basic researcher, you can escape from these ethical or responsibility issues. I think at least that's what I learned. Then what do? So I only have a few slides to say, at least in the softer part of my research, saying in terms of AI governance, we may not need to introduce the entirely new set of governance structures and rules. We can make use ESG, which is extremely well established in the business world. We can use SDG, which is extremely well established among governments. And then you can actually do a reasonably straightforward mapping between responsible AI, I mentioned, SDG, and ESG. Okay, so I won't go through this detailed mapping. So the key message I want to emphasize is saying, if we are going to generate an AI governance structure, do not impose an entirely new set of rules on researchers, developers, and the users. I think it's highly possible to exploit the synergy between responsible AI and the existing frameworks. I think that's good to everyone. So at least I put in a qualitative argument how this technology level responsible AI can be synergized with a corporate level ESG with this global goal of sustainable development. So if I'm interested, I can say more afterwards. But the key message is AI governance does not mean we are getting a huge burden from a new set of government rules. Okay, Second message I want to get from this is AI ethics and the governance is not AI researcher or users business only. It's really need a concerted multi-sectorial, multidisciplinary approach. And I can say quite a lot. And one example to illustrate that, I can always ask you, you know this explainability is very popular in AI, XAI, explainable AI. And I mentioned that these AI system need to be transparent. Now I can give you a little test. And then, are there any differences between transparency and explainability? Okay, when I look at the AI system, sometimes I say, oh, your system needs to be transparent, especially sometimes Europeans or Americans say, oh, the Chinese AI system not transparent, not explainable, okay, they use. Do you think there's a difference between transparency and explainability? Very interesting, yeah.
I'll just make a comparison of open kitchen.
Yeah.
Right? You can see how your cooks actually operate in the kitchen, but you don't necessarily know what the ingredients they use. Are they, qualified for hygiene? That's
I think that's a very important, very good answer. I think that these are actually very different concepts. And then it mingle with, especially from engineering and business point of view, mingle with a different thing, okay? Explainability normally focus on the model and the algorithm. But transparency, you can be transparent in terms of information, training data, for example. Then you have the balance conflicts, how much I reveal, because of privacy issues. I don't want to tell you all the information, data I use for training. Then there's a transparency in terms of the algorithms and the model I use. I may or may not want to tell you everything because that's my IP. If I tell you everything, how can I get my survival strategy? I need to rely on something, right? Then there's a third level of transparency. It's about my system. How do I build my system interacting with the hardware cloud? And then all this GPU stuff comes in. And there's a lot of know-how. Okay, I may or may not be able. I think there's a fine balance. So explainability to me is only a very small part of transparency. Something can be explainable, but might not be transparent. Explainable to me will not be transparent to someone on the street. So that's why I said something is AI ethics and the governance is very multi-sectorial and multidisciplinary. Then final part is to look at this technological approach. And so far I talked about very, very woolly, hand-waving, very qualitative. But actually with a strong technical background, there are a lot of interesting stuff we can do. So if I give you a partial list of very active research areas. So these are the principles I mentioned from transparency down to privacy. And then if you look at the research topics in so-called AI conference journals, these are actually technical terms you can type in Google or you can actually use the index to search for papers. Every topic, I'm sure you get the hundreds or even thousands of papers, right? Explainable AI, safe AI, fair AI. And then all these privacy stuff actually has been there for quite some time. So the final two examples related to this, and then I'll give you one example in this domain, the other example in this domain. And the primary objective is not for you to understand every bit of techniques, because that's what I do. I spend lots of time, and surely it's quite difficult for you to understand in a few minutes. But I want to illustrate some of the struggle I went through. And I want to share with you which you may or may not encounter that struggle. Okay, let's say I want to build a machine learning system which is unbiased. I won't get into the example I mentioned. I have an algorithm where there's a certain bias for or against between certain groups like a white or black, or people wearing glasses, people without wearing glasses, people with accent or whatever accent, okay? That's a very hot research topic, okay? So let's, believe me, it's a hot research topic. Now, here's the struggle I mentioned. Fair, what do you mean fair? I asked you, I don't know, 10 or 20 people here. You will give me more than 20 different definitions. So in the literature, there are 23, at least by the time I wrote this paper, 23 different definitions of fairness. All of them written down mathematically, okay? No ambiguity. All of them are correct because capturing certain aspect of fairness. So just trust me, and then if you want to decide some more. Then you say, oh, that's good, very good. And then the more the merrier, because if a PhD student, I'll invent another fairness metric, and then he or she can graduate, and then I'll write another proposal to get another 2 metrics defined. The challenge is here. There are 2 challenges. Whenever you consider these ethical principles, you sacrifice your accuracy. Then you say, oh, Professor Yao, you are not so good. You know, if you ask Alex, he'll be able to find a solution, no problem. But I can show you mathematically there's an inherent conflict between raw performance, like accuracy, and principle you pursue, like a fairness. You just can't get 熊掌和鱼不可兼得. Okay, just trust me. Then you say, then what do I do? Because I cannot develop a system saying this is 99% accuracy, but somehow it's biased. You'll be in trouble, okay? The system can write a paper, but it will not be deployed in the real world. And then you say, okay, I'll get the 100% unbiased system, and then but accuracy only 80%. Still, people won't use it. So that's the first conflict. The second interesting conflict is when you have so many different metrics, there are inherent conflict among different metrics. For exactly the same system, if you use one metric to measure it, it says unbiased. If you look at from a different metric point of view, it says it's biased. Again, if you want to deploy the system in the real world, you cannot say, well, let's hide these biased metrics. People will know because it's in the literature. So this is actually a computational visualization we did. If you look at this dark blue one, and this is actually 25 different metrics. The dark blue one, that means that between that pair of metrics, they are in conflict with each other. If you improve one, the other one will get worse. They sound like an impossibility now. You want a research challenge? There you go. That's a research challenge. So really, and then it's very simple, simplified research question is how can we make this machine learning fairer according to different metrics, but at the same time without sacrificing accuracy too much? Okay, so that's the research question. Very specific post. So the answer in my case is very straightforward, given my background in evolutionary computation. Please do not combine the entire world into one metric. So for those of you with a machine learning background, please don't squeeze everything into one loss function. The real world is always more complex than one function. In this case, and I said, why don't you have multiple functions for your learning? Then you have a slightly different research area in terms of how do you learn with these multiple objectives. Okay, I'll skip these details. The second example is very similar to reinforce the message I mentioned. people are interested in explainable AI, not only papers or even books. Then we are faced with a situation that you have one technique for explainable model, there's another one saying mine is better. Then as a scientist, or even as an engineer, you say, but on what basis you say one is better than the other? Okay, and they say, oh, we need to measure it objectively and quantitatively. For example, we can measure it in terms of faithfulness. If I have a very complex, large neural network model, I use a simple one as an explainable model. Then I want to make sure this simpler one will be truthful to the original complex one. You can't come up with an arbitrary explanation, okay, so the truthfulness. And then the last one is also very simple. If you want to have an explainable model, you want this explainable model to be as simple as possible. If it's as complex as the original one, you don't get anywhere. Okay. Interestingly, you can discover this inherent conflict between these two. You can imagine if something very simple, probably it might not be so truthful. Then you say, have you invented these scenarios? Let me give you another example such that you can appreciate why it's important to look at these different scenarios. Assuming I'm into AI plus health domain. We all know Hong Kong government is very interested in healthcare, especially elderly care. Okay. And then I developed this magic AI system for diagnosis assistance. Then it's, I don't know, 100 billion parameters model come up with a prescription. Then of course, I will never follow a prescription generated by machine. I still trust human beings. I always encourage you to use it. Then you say, no. Please let me know how you decide on this particular prescription, right? You need to tell me what's the diagnosis, how you arrive at this diagnosis. Now, this so-called explanation will be very different if you want to explain this model to a fellow machine learning developers. For example, if you want to explain a very complex black box to another machine learning developers, in my view, a Bayesian network will be perfect because it's statistically sound. Okay, I can do analysis in terms of priors, in terms of conditional distributions. But just imagine if you give a Bayesian network to a patient. He or she say, you must be joking, right? Because as a patient, he or she would prefer much simpler explanation at the price or at the sacrificing the so-called truthfulness. If you want to explain to a doctor, I think doctor will emphasize the internal reasoning step a lot more than the final outcome. So explainability can mean very different thing for different so-called stakeholders. So how do you generate these different explanations? So it's not one explanation anymore. It's actually multiple ones. So this is actually formulated as a kind of a more manageable research question for a researcher. How do you first balance the trade-off among different metrics I just mentioned here? Secondly, is it possible to generate multiple explanation models for multiple stakeholders? So there's not a single one there. In my particular case, I still formulate it as a multi-objective learning problems because I believe for all these ethical principles, it's not possible to be captured by one quantitative metric. Even when you come up with the multiple ones, we need to be aware what might be missing outside these multiple metrics. Okay. So the rest of details I go over. So for the time I have a very simple 3 messages one, I have oversimplified all my arguments saying what's trustworthy AI, in case you are persuaded by me. It's very simple. It's a traditional trustworthy system with other 6 properties plus AI ethics. Okay, that's trustworthy AI. That's what's new in trustworthy AI. It's not just a buzzword, because ethical principles are very important. Secondly, I hope the tree I show you about AI ethics can give you a notion that the concept of AI ethics, especially in the context of engineering system, is a complex, hierarchical, and multidimensional. Even I zoom into just one ethical principle like fairness, you actually need to describe it as a multi-dimensional space rather than a single dimension space. Okay, so when you see a paper which compress everything into one value called ethics, you know it's a very, very coarse approximation. Last bit is if we are truly interested in trustworthy AI, we should not indulge ourselves only in quantitative methods. I think qualitative methods are also important. I use these two to show in the last 2 years, 24 and 25, we have been organizing this small-scale workshop. For this workshop, we have 1/3 people with a technical background, a bit like me. 1/3 actually more from the legal domain, because they are very interested in governance from regulation point of view. 1/3 are social scientists looking at the social implications when you develop certain technology. So we are planning the 3rd one in Hong Kong again in November. So I will let you know, and I invite you to attend if you're interested. I'll stop here, and thank you very much for your attention. Yeah.